Hi, and welcome to lesson 6. So today we'll be doing unstructured meshing for NACA 18, NACA 12 aspect ratio 5 wing, and just going to open ICEM CFD 15.0 is the version I'm using. And just before we start anything, I just want to show you the geometry. So I um, got my wing in the middle of let's rename this as far field, and this body is actually the fluid zone, so I'm going to rename it as fluid. Okay. So we got our geometry, and like I said, it's a three-dimensional wing on NACA 12 with aspect ratio 5. So I'm going to unclick my far field just to show you the wing with a blunt trailing edge, and some options that I've already chosen, which I'm going to undo now. Okay, so the approach that we are going to use today is called unstructured bottom-up approach in ICEM CFD. So it's you start with a surface mesh and you improve the surface mesh until you are happy, and then you create a boundary layer using prisms, and then on top of that you develop a volume mesh for the fluid zone. So again, so you first generate surface, then you generate the boundary grid, and then you generate the volume grid. And this is called the bottom-up approach. It can be applied for both unstructured and structured type of grading in ICEM CFD, or basically any software. And in most of the softwares, I should not say any software. And the top-down approach is the reciprocal of this. So we'll be generating the volume mesh and the surface mesh together in one go. But I am a fan of bottom-up approach, and I like to make sure that my surface mesh is of good quality before I go ahead and develop a volume mesh. So let's go ahead, and I'm just going to untick the fluid zone because I want to fit into the wing. The first thing I like to do is work with curves when I'm doing an unstructured mesh. So I'm going to go into mesh, curves, general, and so I have selected 1, 2, 3, 4. Oh, before that, I just need to say one very important thing. So I have built the first thing you need to do is go into build repair geometry and build topology. But since I've already done that, all the curves are in red color, so that means the curves and the surfaces are well connected, and it's a watertight or airtight geometry. So basically it's referred to as airtight or watertight geometry, which means there are no holes or gaps, or it's good quality geometry basically. Yeah, so let's go again to mesh curves, and I have selected already some values, but I'm just going to show you these values. So general, and 62 nodes, these two, 62. So I've selected individual curves and done 62, and on the horizontal front curves I have selected, from the leading edge and tip curves I have selected 300 nodes for every curve. So they all have 300. Remember that they all need to have the same amount of they don't need to in unstructured mesh, but I prefer to have the same amount of nodes because I'm going to use something called I'm going to use something called auto block for quad for try. So if you don't have the same number of nodes on the matching parallel curves, then auto block is not going to work. So I have not shown you these small curves here. They are made up of 14 nodes, just enough to capture resolve the leading edge well. 14 and 14. Okay, so it's good. So if I go into dynamic now and I set some ratios, so it used to be 1.0 uniform, but I went into bigeometric, which means change the ratio in the end and in the beginning of the curve, so from two sides. And then I went into bunching ratio and then selected this curve. When it highlights, right click on the mouse and then it changes to 1.1. So I change it to 1.1 for all these curves here, all these curves here, and all these curves here, except for these very small curves I didn't do it. And the number of nodes in these small curves is set to 5 nodes, so I'll have 4 cells. So 5 nodes, 1, 2, 3, 4, 5. I can actually show you the spacings now using curve node spacing option turning on. So because I have set the bunching ratios using dynamic option to be 1.1, the spacings automatically changes. So if I have, for example, selected here that the spacing is 1.0, then it's a uniform distribution. But I went ahead and I chose bigeometric and 1.1, so it's smaller towards this end and smaller towards this end. You can even change it to 1.2, which means it will be more smaller, or you can even go to general and just select this curve and specify the spacing in the spacing 1 and spacing 2, make it smaller, bigger. So it's up to you to do that. Okay, so first thing, like I said, is I like to set the right settings for the curves and right spacing values and right number of nodes which matches the parallel curves. And after that, just go ahead and I mesh all my curves. I click apply, mesh curve, apply, and it says here 1794 was created. So right now, if I turn off my geometry, I have only lines as my grid. So each of this is, if I go to edit mesh and delete, just to show you, each of this element is like how I specified. They are smaller towards this point, larger towards the middle. So I'm quite happy with that. And now I'm just going to go to the surface mesh settings. So I need to turn on the surfaces on, and I'm going to select first of all these two surfaces, and I have selected that the maximum size is 0.1. Let's reduce it to 0.02 or something, maybe 0.05. It doesn't really matter because we are also selecting here all try and auto block. So auto block means it will kind of formulate chords and then divide them into triangles using an auto blocking that the software does, rather than just formulating some triangles over there. So you will see the results in a bit, and then you can kind of compare the difference by yourself. So I'm going to select these two, and I have selected that the top surface and the bottom surface will be all triangles, and the mesh method will be patch dependent because I want them to respect the line elements that I have just made before. And the size is 0.1. I can try and reduce that to 0.08. And why I am seeing these triangles here, because I have gone into surfaces, right click, and said I want to see the tetra sizes. Okay, so before I went in curves and said I want to see the curve node spacing, I can turn that off now because I know what's happening with my curves. I'm going to surfaces and I'm going to yeah, if I didn't have the tone it will be like something like this, but since I want to see what sizes I'm setting, I can so that I know what's happening with my mesh. Okay, so that's 0.08, still looks quite big, so let's 0.04. Okay, I'm quite happy with that because I don't want the mesh to be too dense in those regions. And in the root and tip or on the sides, I'm just going to select a smaller size of 0.01. Also select all try and patch dependent, click apply. And for the trailing edge surface, I like to use quads rather than triangles. So I selected that surface, I selected all quads and auto block. So remember, auto block for this surface, the tip surface, the trailing edge surface, and auto block for these two surfaces, these two, the leading edge surfaces. Okay. But for the leading edge, I'm using auto block all try. But I can actually, to be honest, it's a bit annoying. But let's change it. Let's change it to all quad for now, just to see what happens. Okay. Right, so now I have generated my mesh in terms of the line elements, but I need to then generate some triangles on top of it. So I'm going to go ahead and go to the general settings first, the global mesh settings, and I'm going to just give a value that's bigger than all these things. So maybe like something like, because my maximum size I set here was 0.04, I can select this as 1 or something, click apply, fine. Even I can display it just to see what it looks like. Okay, so this is not for the, this is the maximum element in terms of volume and surface and lines, everything, so all kinds of elements, the global element size. Now I go into my surface. I don't play with any of this because I've already individually selected to override the global settings, and I want to tick on this option, respect line elements, while I'm making this surface mesh, so that the surface mesh will form according to the line elements that I have specified, the curve spacings. Okay, now I'm going to go ahead and say, okay, actually I need to set some spacings for my my far field as well. So I'm going to go there, my far field. I've already specified some spacings for my far field, and I just want to check if everything is okay. So the maximum size is 12 there, and it's all try and patch dependent, apply. I click remesh, which was a problem. Okay, I didn't need to do that. Right, so field surface delete. Okay, so this is my far field, and let's set it again. 1 2 3 4 5 and 6. Okay, maximum size 12, all try, patch dependent, apply, dismiss. And with the curves, I don't know if I have done lines for, I have actually done lines, line elements for the curves as well. So okay, let's go ahead and generate our surface mesh. From screen, I'm going to select everything that's visible and select compute, even though it says quad dominant and patch dependent here, since I've individually selected all surfaces settings using this option here, surface mesh setup, is going to override the global settings, so don't worry about that. And I'm just going to click compute, see what I get. It's gonna take some time. I'm gonna pause the video and come back. Okay, so the surface mesh is done now. There was a little problem actually. I forgot that the far field, I was doing the surface mesh for the far field as well. And in the global settings, the maximum element should be 12 rather than 1, because these elements are much bigger when they come to the far field. So I'm just going to untick the far field for now, zoom in and see how the mesh looks like on the turn off the geometry as well, and go into a solid view and see how the mesh looks like. So for the purpose of this tutorial, this is decent. We got our auto block codes here. The this triangle surface mesh is respecting our line elements, and we got a good enough resolution here, but we could definitely improve on the trailing edge. But quite happy with the trailing edge codes that we used to capture. Let's have a to formulate this trailing edge chords rather than using triangles. So this will be how to generate the surface mesh. Maybe in the next video I'll explain how to, because it's already about 16 minutes. In the next video I'll explain how to generate prism layer, boundary layers on top of this, and generate a volume mesh. Thank you for watching.